Hi guys. So today we're going to look at solving exponential equations and natural log equations. Now before we get started, I want to think about first, what is e raised to the natural log of x? Now if you remember, the natural log of x is a log base e of x. So it's asking e to what exponent is x. So what we're saying here is this is the exponent on e that is x. Now when we find this exponent, we're going to put it right here. So we're going to have e to this question mark, but we already know that e to the question mark is x. So it turns out that e to the natural log of x is just x. That if the base of the exponent and the base of the log are the same, they're going to undo each other. So e to the natural log of x is x. Very important to know. The next question, and this one's a little easier to understand. The natural log of e to the x, by our laws of logs, we know that that x comes down front because when we raise an exponent to an exponent, we multiply. And we also know that the natural log of e is 1 because e to the 1 is e. And then that just gives us x. So both of these end up in a result of x. And the reason that happens is because the natural log of x and e to the x are inverses of each other. So when we do the composition, when we have the exponent and we put the natural log of the same base inside it, or we have the natural log and we put the exponent of the same base inside it, they're undoing each other. They are inverses of each other, and we end up right back where we started at x. So that means that e raised to the natural log of x to the fourth plus 1, think about it, the e and the natural log undo each other, and we have x to the fourth plus 1. And if we have the natural log of e to the 3x plus 2, again, the natural log and the e undo each other, not cancel. They're inverses, they undo each other, and we get 3x plus 2. Okay, now that we have that, let's go on to solving an exponential equation using natural logarithms. So an example would be 4 to the x equals 10, and we want to solve for x. Now when we do this type of equation, the first thing we want to do is we want to isolate the exponential. That means we want to get this part, the base raised to the exponent, all by itself. So that's already taken place in this particular problem, so we don't have to worry about it. Now we're going to take the natural log of both sides of the equation. So we're going to take the natural log of 4 to the x, and it's equal to the natural log of 10. Next, we use the laws of logs to simplify. So when we have that exponent on the 4, it comes down front, okay? Now we can solve for x. So what we do, to get the x by itself, we divide both sides by the natural log of 4. And x is the natural log of 10 over the natural log of 4. Now, this, my dears, is the exact value. That's the exact value, and that should be our answer. Okay, unless they ask us to round it. So if we were to type that in our calculator, it does turn out that this is about 1.661, and this is what we call the approximate value. And we only use this, only if you are told to round your answer. If you're not told to round your answer, you stop at the exact value. You don't touch the calculator. You don't go to decimals, okay? And for the most part, we're going to be looking for the exact value this year, okay? Let's try the next one. Now we're going to start with a log equation, and we're going to try to solve that. And we're going to use exponentials to do that, just like when we solve other equations way back even from middle school. When we had multiplication in it, we used the inverse operation division. When we had addition, we used the inverse operation subtraction. So when we have logs, we use the inverse operation, the exponential function. So just like we did in the exponentials, and we had to isolate the exponential, now we're going to isolate the log. So again, the natural log of 3x is all by itself on the left-hand side of the equation. So that's good. Now we're going to change the form. We're going to put this in exponential form. So the base on a natural log is e, okay? And remember, this is the exponent because a log is an exponent, so it's always equal to the exponent. So e to the 12th is going to equal 3x. Now you solve for x. So in this case, we're going to divide by 3, and we have x equals e to the 12th over 3. And that's my exact value. If I put it in the calculator, I'm going to have to round. And nowhere in my directions did it say round, so we're not going to pick up a calculator. Now, there is another step on this. You need to check. And what are we checking for? I want you to remember something about logs. Remember the domain? The domain on a log function is whatever you're taking the log of has to be greater than 0. So you need to check and make sure that you're not taking the log of a negative number, okay? You can't take the log of a negative. Now that doesn't mean that your x can't be negative. It means that when you take this answer and plug it back in here, that can't be negative. So remember, this is what I'm saying. The natural log of 3x would be the natural log of 3 times e to the 12th over 3, which is the natural log of e to the 12th. Okay, I can do that. Not a problem. Now, let's try 2 more equations, one of each type. So here we have an equation with a log. 5 times the natural log of 4x equals 20. So step 1, we want to get the log by itself. We're going to divide both sides by 5. So the natural log of 4x equals 4. Next, we put it in exponential form. Our base is e, the exponent is 4, and that's going to be equal to 4x. Now to solve for x, we have to divide both sides by 4. So x is e to the 4th over 4. And if I was to plug that back in here, 4x times this is going to be a positive number, so we're okay. That's our answer. We get to stop right there. Now we have 10 equals 6 times e to the 0.5x. Now in order to do this, first step, we isolate the exponential. So we're going to divide both sides by 6. And if we divide both sides by 6, we're going to have 5/3 equals e to the 0.5x. Okay, now we take the natural log of both sides. Now, according to our laws of logs, on the left-hand side, we're going to have the natural log of 5 minus the natural log of 3, right? Because when we divide, we actually subtract the exponents, and logs are exponents. And this is equal to, and we just said that the natural log of e to an exponent is just that exponent because the natural log and the e are inverses. Last step here, we want to get the x by itself. We divide by the 0.5. So x equals the natural log of 5 minus the natural log of 3 all over 0.5. Okay, guys, there we go. See you soon.